Okay, so welcome everyone. Hello, good morning. Good, there you go. Now there's 4 people awake. Thank you for inviting me. I was a little bit nervous to come here, to be honest, and I kept saying it to Russell because, you know, I've not, like, the last time I touched anything C or C++ related or native or anything like that is about 25 years ago. And I was speaking to Phil, my colleague, Phil Nash, and I said, you know, I'm a little bit worried. And he's like, oh, don't be worried, just don't say anything offensive. I'm like, I mean, why would you think me or people saying anything offensive? It's like, no, I mean, you know, don't say things like, you know, C and C++ is the same language. I'm like, oh, come on, man, give me a little bit of credit beyond that. But anyway, I am here. I'm going to talk to you a little bit about Kotlin and the language, and then what we're doing with Kotlin Native, and yep. So before I begin, why Kotlin? And I always like to run a poll, kind of how many people, just to also notice that you are actually in the room, how many people know Kotlin or have used it or worked with it, have heard of Kotlin before Google I/O? There you go. Like, I spent 6 years of my life talking about Kotlin, no one's heard of it, and then Google go and say it, and everyone's heard of it. Just been on the beach for 6 years. Anyway, why Kotlin? So why did we do Kotlin? So we were looking for, at JetBrains, we make tools, developer tools, and most of the developer tools that we make are based on the JVM, so they're using Java. So we were looking for a language that was a little bit more concise than Java, which isn't a high bar to set. We were looking for a language that was kind of safe, a language that was expressive, toolable, because that's what we do, we make tools, and modern. Now, I don't exactly know what a modern language is, but we threw modern in there anyway. And so we were looking around, and one of the candidates, of course, was Scala. The main problem we had with Scala, and especially back then, is that Scala was quite a language that is difficult to tool. And to give you a comparison, for instance, right now we've got about 3 people, I think, working on the Kotlin support for Kotlin in IntelliJ, and just for the Scala plugin, I think it's roughly around 11 or 12 people. So it's significantly harder as a language to tool, and we had performance issues, et cetera, et cetera, et cetera. So we thought, well, you know, looking at some of the alternatives, we decided to write our own language and hopefully use it. But above all, I think that one of the things that we wanted to take away from this is pragmatic. And I hate using the word pragmatic because it's completely overloaded. But yes, essentially pragmatic. Something that would look at the issues that we face on a daily basis, the grunt work, the pains that we go through as developers, and try and resolve that, which is basically in line with some of the things we do with our tools. And I want to focus a little bit on the concise and expressive, because you can have languages that are concise and yet they lose the expressiveness. And why is this important? And we go back to the concept of clean, or clean code, as some would put it. And I've got some wonderful quotes that I won't read in total. I'll just highlight some things that are said. You know, when we talk about clean code, the logic should be straightforward and make it hard for bugs to hide. The dependencies minimal to ease maintenance, right? Clean code reads like well-written prose. Or you know you are working with clean code when each routine you read turns out to be pretty much what you expected. Okay? So these are some quotes that people have, very famous people have given on clean code. And so let's take a Java. Now, I don't do, as I said, I don't do C++, so I don't have the equivalent of what would be a POCO. But this is a POJO, which is a plain old Java object. And this is essentially a DTO, right? So I'm just data that I read and write to, and it doesn't really have any behavior. And we wanted to condense this down into this, right? And that's essentially the idea behind Kotlin. Not to have a single line of code, but the fact of removing a lot of boilerplate code, and at the same time, hopefully today, as I'll show you some code, demonstrate that we still keep that code concise and expressive. So the point is removing noise and focusing on what the intent of the code is. So when I read the code, I look at exactly what the intent of the developer is, and if I don't understand, I hope that they've left some comments. But as Kevlin once said, that there's this perception that people that don't know how to write good code apparently know how to write good comments, which is false as well, right? And that is essentially Kotlin, right? This is what we've tried to do. Now, when we started it on the JVM because that's what we do, that's what our tools are. We run on the JVM. And then at some point we said, well, let's do JavaScript. Why not? Because everyone else is doing JavaScript. Why shouldn't we? You know, potentially get a group of hipsters to use our language. That's a true story. And then at some point we're like, well, we've done JavaScript. Why don't we just do native as well? And that's where we branched into native. Now, Kotlin started to take off quite a bit in the Android space because it was compatible with Java 6. So, you know, Android developers lacked their lambdas, so we gave them lambdas. And we thought, but we can extend this to other platforms. So now Kotlin Native will target iOS and Android native. It will target macOS, Linux, Windows. Does anyone run Windows? Okay, small group of people. WebAssembly and embedded, right? So this is the direction we're going with Kotlin Native. And I'm not going to get into too technical details because I don't know them, but I'll show you a little bit of technical details after I show you the language. And talking about the language, let's take a look at the language. Now, you're going to have to forgive me because I'm going to try and do some live coding, which is bad in itself. But on top of that, I can't see my screen because it's kind of like bent. And I can't put it straight because obviously I could put it. You're like, why won't you put your screen straight? But never mind. Just ignore me. OK, so I'm going to look over there and type here. And hopefully it will work out. But before I do that, let me show you my Vim skills. Because, you know, we do tooling, but I do know the core stuff as well. It's always like, you know, they say, understand the things under the covers, right? So I understand Vim. So I can write fun main args, array of string, and I'll explain this when I say print line, hello, ACCU, right? OK, and I don't know how to exit Vim, so I'll open up and so hello, Kotlin. That's Conan, our native compiler. So that's hello.kt, and that will generate a native application, right? And now it's called program.kexy because someone had this bright idea that anything related to Kotlin, we just prefix a K with or replace a C with K, which is a very cool idea until you see it a million times. So I'm going to make this more kind of like native to macOS, and I'll just call it program, right? There you go. Now it looks more like, yeah, that looks nice, right? And then if I want to run it, I just run it, and I get my native application. OK, so that shows you, Kotlin Native exists as a library. You don't have to use our tools. And it shows how awesome I am at Vim. OK, so now that we've seen that, let's go to my real editor. And so let me show you a few things around the language. The first thing that you saw is, let's go over to main over here, not main, there we go, right. So that's essentially the same thing that you saw in the other place, except now it's exactly the same. And as you can see, in Kotlin, we have the concept of top-level functions, right? So you don't have to have a class and then have to have a static method around that class. You can just have top-level functions. And as I always say, it's kind of like JavaScript, but in a good way. So any function that matches this signature per package, per file, essentially means that that's the entry point to the application. And by the way, Kotlin also provides support for scripting. So one thing that we saw was the data classes, right? And here you saw that, you know, essentially I have like a class, and that's, for example, customer. And then what I'm doing here, where we saw in the example, essentially I have some parameters that I'm passing in, but these parameters are not only parameters, they're also properties. So in this single line, what I'm doing is declaring two properties. One of them is ID, the other one is name. ID has a prefix of val, which means that it's read-only. in essence, immutable, so to speak. Var means it's read-write, okay? So this would be the equivalent of me creating a constructor, passing in 2 parameters to the constructor, and having 2 properties, one of ID and one of name. There is no such concept as a field in Kotlin. If you want to have a field, you would essentially have a private property. And this generates what I just said. Now, when I add the data to it over here, at the beginning, I add the data modifier. What that does is then that implements for you behind the scenes the toString, the equals, the get, the hash code, and the clone function or the copy function, giving you all of that, right? So now I can do, for instance, main, and I'll do val customer equals customer, 1 me, and then here I could do, for example, customer1 equals customer copy, right? And that essentially makes a carbon copy of my customer. I can change the parameters if I want. It does a deep copy, so if I have an array of customers and then they have an array of contacts, then it will do that copy as well, okay? But a class, you can just define a class. You see that as soon as I remove data, then the copy's gone. But that's how you define a class, and you don't need to actually have a body. So the class doesn't need to have a body if there's no actual members inside of it. Now, a few things that we do different from Java and some other languages is that our classes are different in terms of behavior when it comes to hierarchy. So let's say that I have a class that I'm going to call employee, right? Now, I have another class that I call person. And if I want to inherit from person, that's going to give me an error. Does anybody know why that would give me an error? Because, as we all know, employees are resources. No, I'm joking. I should do that at an Agile conference. They'll kick me out for life. Kind of like what you're going to do after this keynote. So the reason is because by default, classes are final in Kotlin, right? So if you want to declare a hierarchy, if you want to inherit from a class, you have to explicitly declare it as open. And this, of course, leads to certain situations where, for instance, people say, OK, but how do I mock this? Or how do I, if I have frameworks such as AOP frameworks that want to inject some behavior through dynamic proxy or whatever, how do I do this? So there's 2 ways. You can either declare everything as open, or we have what we call the compiler itself has this architecture, plugin architecture, which allows us to inject certain functionality, right? So we have developed, for example, functionality for certain frameworks, such as Spring Framework, which requires things to be open. And you say certain classes, by default, at the level of Spring, treat them as open. So you don't have to, add a lot of noise to your code base in this sense. Okay? So that is one difference in terms of classes with Kotlin and hierarchies. We also have the concept of a sealed class. So for instance, if I have a class over here, now that I've declared this class open, if I create a new file here, for example, blah, blah, and I can come here and say class contractor, and say contractor, and say that this is also a person, right? That actually works. Now, if you want to represent what would be the equivalent of what's known as like an algebraic data type, which is essentially a type that is of one type or another type, in Kotlin, if you declare them as open, it allows for extensibility. So you can kind of seal off the behavior of that with sealed, right? So once you add sealed instead of open, you're essentially saying that I'm sealing off the hierarchy to what is inside this file. So the hierarchy is closed specific to a file. Okay? So if I go back to my blah, blah, that should give me an error saying that I no longer can inherit from this. Okay? In Kotlin, so we have, it's an object-oriented language that is statically typed, that is has functional paradigms. And you might say, OK, well, what is a functional paradigm? Well, it depends on who you ask, right? That's one of the beauties, right? It's kind of like a consultant, right? What is functional programming? It depends. Depends on what? Depends if I know how to help you or not. So that was no attack to consultants. So the point with regard to functional programming in Kotlin, we can treat functions as first-class citizens. And we'll see a little bit about that later on. But we have objects, right? So we have classes, and we can create instances of those classes. We saw that you can create an instance of customer, so I can say val customer again, customer, and that creates one instance. I can create 100 instances of it. But what happens if you just want a single instance? So we also have the concept of singletons. So I can just say object, my singleton, and that's it. And that is essentially the singleton pattern in Kotlin. Right? So this would be kind of like equivalent of JavaScript, which is everything object. In Kotlin, everything is class, and you can create objects kind of like JavaScript. So in other places where we try and be a little bit more concise is in terms of the functions. So for instance, I have a function that does something, and you see that we follow the Pascal notation. So I say A, int, B, string, and this is essentially, print line, with string interpolation, so that would be A, and I can even do like complex or call a method or whatever on that, right? We have optional parameters, meaning that if I want to just set a default parameter, I can. So now I can call does something with just a single parameter, right? So I could say single, I could do name parameters, and I could pass in the second parameter, etc. Okay? So we have named parameters and optional parameters, default parameters. This means that we cut down what? On all of the overloaded functions that we have to create over and over again, right? Because we can just have default parameters. And the same thing applies to constructors. So while there is the concept of secondary constructor in Kotlin, normally when you have a class, you're essentially just, if you want a secondary constructor with no parameters passed in, you just assign defaults to the current parameters. And in terms of conciseness, again, notice that when I declared, for instance, a customer, as opposed to Java or some other languages, I wouldn't have to say, declare it as customer like that, right? I don't have to do anything like that. Well, I wouldn't ever do that because that's Java in Kotlin. But I wouldn't have to do something like val customer. I don't have to define the type, right? So, well, customer data class, customer. A, int, B, string, var, val. Okay? So I don't need to explicitly declare the type. I can, of course, like this, but we try and use inference as much as possible, right? So there I'm declaring a read-only customer and explicitly not having to declare the type. I just initialize it. And we have the same kind of thing in functions. So for instance, this function by default is void, right? So when it's void, you don't explicitly have to mark void. Well, you can write unit, which is void, but it's not void. It's different to void. It's kind of like void, but it's not void. It's an object, right, which has a function toString, which returns kotlin.unit. But if it doesn't return a value, if it returns unit, then I say that it's void. I can omit it. Now, there's also a different type of thing. This is different from not returning anything, because we also have the concept of not returning anything in Kotlin. So for instance, if I were to take this function, and I write throw exception hello, right? If I call this function over here, let's say does something, and then I write print line here, you can see that nothing's going to happen. I mean, the compiler is going to just think everything's OK because it's going to run that function, but we know that that function is never going to actually return because it is throwing an exception. Now, according to the compiler, that function is going to return. What is it going to return? It's going to return an object called unit that I can even query on. But what if I want to tell the compiler that that function never returns? It returns nothing. Then I can just say it returns nothing. Okay? As soon as I add nothing, then the compiler now knows that this is unreachable code. And you wonder, what is nothing? Nothing is nothing to worry about. Nothing is a class with a private constructor, essentially. So in the type hierarchy of Kotlin, we have nothing at the bottom, literally, I mean, no, nothing. And then we have the types, and then we have any at the top, which is the equivalent of object. Okay? So this kind of type inference we have in functions as well. So if I have a function, for instance, sum, which is x int, y int, instead of having to do int like this and then do return be explicit x plus y, I can actually convert this into a single expression function by just saying equals x plus y, right? So that now is cutting down on the explicit type declaration. It's saying that this is an integer, and it's returning that. And essentially, if you think about it, any function can be expressed as a single line expression, especially if you have a 4K monitor, because that whole 80-character column thing, that's just gone away. But you can essentially do that. And in fact, for instance, in Kotlin, if you take a look at conditional expressions, conditional statements, if, when, etc., these are treated as expressions as well. And in fact, we favor that you treat them as expressions. So here, for instance, you can see that I have a parameter that is a conditional. If arguments is empty, return 100, else return the first argument. Here, I have multiple else if branches. And notice that I'm just putting one value on a line. And that essentially is the last line of that branch is the return value from that branch. Okay? So in the case of when statements, which would be equivalent to kind of switch, here you can see that I have what would be kind of like a little bit pattern matching as well, right? I have like 1, 2, I can check within a series of values, I can check whether it's a specific type, whether it's in a list of a range of values, I can even call a function, etc. And in each branch, I can return whatever I want. So if I return a string here, you see that now the compiler is highlighting it because it's saying that now actual has been cast to type any, because different branches are returning different types, okay? So it does allow you to do that if, of course, it makes sense. And these are, again, trying to why would we do this? Well, because this, treating when statements, conditionals as an expression, allows us to cut down having to explicitly declare a variable and then assign that variable based on the result. We can just do it all in a single step, okay? And we do a lot of these things. Like, for instance, going back to our people, or wherever we work. So I have, for example, class, ABC, and then I have a function that says, take, for instance, an object, and object can be any, and then I'll say, do something, do it. And then we'll say that this has a method fun called hello. So now, if I do like a check, so if I say if opt is of type ABC, I can do then ob.hello. And notice what's happening. It's missing the casting, right? Because the compiler is inferring that this is a safe operation. No other thread is going to change this, so I will automatically cast this for you to type hello. And you can see that there it's green highlighting saying it's smart cast. Okay? Again, if you're using a tool like IntelliJ or whatever, Alt-Enter and we'll do this for you. Yeah, we kind of didn't put 2 and 2 together and saying that if we start removing these features, how are we going to sell tools? But we'll figure that one out later. And this, in fact, you see quite present also when we're talking about nullability, right? Because nullability is one thing when we're talking about something safe, that's one thing that we've gotten rid of in Kotlin. So by default, if I say val value equals string, and if I say value equals null, that's not going to work. Why isn't it going to work? For 2 reasons. One, because this is read-only, so I would have to declare this as read-write. Notice when I do that, the IDE underlines it, right? Because why does it underline it? Because we do not enforce immutability, we promote it. How can you promote it? By making something really annoying for developers. How do you do that? Make their fonts underlined. Seriously, that also is a true story. So value there cannot be assigned null because by default, types in Kotlin cannot be null. So if I want to be able to declare this as null, I have to explicitly mark it as nullable, adding the question mark. Okay? And this now cuts down, again, the possibility of us running into null pointer exceptions at runtime. So essentially, if you're working with Kotlin, you by default don't need to use null. If you're trying to interop with something else, whether it's C or whether it's Java, etc., then you might need null, because the concept of null exists in those languages, and thus we have the ability to do that in Kotlin. And when you do that, then you end up in situations where now I've got to do if value is not null. By the way, did you notice that? Yeah? It's funny because I always do like these 1-hour talks on Kotlin, and I'm like, any questions? And they're like, yeah, how did you get those arrows and nice looking fonts on your IDE? I'm like, no, about Kotlin. No, we just care about that. That is font ligatures in IntelliJ. You can enable it. Okay, so here now I would have to do if check not null, and then, for example, do print line value dot length, right? Dot length. Again, notice here that there's a smart cast saying I've now cast this to type not null, because you've already checked that it's not null. In order for me to cut this down, what I could also do is do print line value length, right? And that essentially is just checking. It's a safe operator to check if this value is not null, then invoke the method on it. If it is null, then don't do anything. So if I were to run this, what would I get? Well, I would get null. Why? Because it's printing line on a value that is null. What's the two-string representation of null? It is just null. You can see it over here. It's 6. But am I running the wrong thing? Yes, probably. Oh, length. Yes. OK, yes. Oh, it's not null. Yes. OK. I'm like, null. OK, right, there you go. OK, now, of course, as I said, this comes into play when you're trying to interop. So how does that work? Well, essentially, we leave it up to you. So if you are working with something that is nullable, you will have to annotate that type as nullable if it's coming from Java, if it's from C, whatever. And then you will have to do the consequent checks. Now, if you do not do the consequent checks, and you don't want to do the consequent checks, you can also do something like that, which is called the double hashbang, which essentially says, I know it's null, but I like to have my null pointer exceptions, so just give me them, OK? And you laugh, but it's sad, because when people start to integrate with Kotlin code, right, they kind of like, they use a lot of stuff from Java, or they start to convert their stuff from Java, and they like look at it and like, oh God, I really don't have time right now to think about the case when this is null, so why don't I, and you're like, well, why don't I just do that? And they're like, no, but that will only work if it's not null, so let me do that. And you're, but what about the case it is null? Yeah, but we'll just pretend that doesn't happen, right? And that is the reality. So in essence, what removing null from a language is doing is making us think about nullability, right? Especially when we are in a situation where we have to interop with existing code base. And we've talked about Kotlin being an object-oriented language with functional constructs. And of course, it is, there are some things specific with Kotlin, well, not specific to Kotlin. I mean, other languages have it, in regard to functions. One of them is higher order. But before we get to that, there's another thing that's nice with Kotlin, which is called extension functions. Anyone familiar with C# here? Right. So in C# you have the concept of extension functions, which means if I have a class that I want to extend, I don't have to necessarily inherit from it. I can just extend it with new functionality. So in Kotlin, I can do that as well. So for instance, if I want to have 2 camel case, right, normally what I would do is have a class called string utils, right, or string helpers. And then someone else would create a class called auxiliary string helpers. And I would have, like, you know, my string utils in there. But in Kotlin, what you can do is essentially take any class, Java or Kotlin, and extend it. So I can say 2 camel case, right? And what this is going to do is extend the string class with a new function called 2 camel case. So if I write a string here, I now have 2 camel case. And that is at the package level. Right, so wherever that is defined at the package at the very top, this is the default package, but you can see that, for instance, here I have a package. Right, wherever that is defined, then 2 camel case will be available. So I could do some things like, you know, let's say, for instance, fun is same as value equals string, and then I can say, well, since this is an actual extension function, it means it has access to the instance of the class that it's extending, which in Kotlin we refer to as this, so I can say this equals value. And that is essentially writing a string comparison. What did I do? Oh, yes, string, right? So now I could say, for example, hello is same as hello. Hello, right? And in Kotlin, we also allow you to do something like this, is the same as hello, by adding an infix notation. So any extension function or member function that takes a single parameter, you can add an extension function, infix notation to it, and then call your functions also in infix notation. And along with extension functions, we also have extension properties. So for instance, you can have val abc equals 10. That means it's an int. Val def equals 10f. That means it's a float. Val ced equals 20bd, which means nothing. But it would be great if in Java we have big decimal, and that could be big decimal. So the easiest I could do is make it like with an extension function like that, but we also have extension properties. So I could just write, for example, bd, and then instead of having this as an extension function, I can have it as an extension property to int, which in this case would return a big decimal. And then here the implementation would be return big decimal of this, right? This. So now you see that I have kind of extension properties as well. And when we look at a little bit how to like use this to leverage it and create DSLs, you see that these are some of the things that allow you to make those nice looking DSLs in Kotlin. But before we get into DSLs, talking about functions as we were, the concept of higher order functions, a function that takes a function or returns a function. So for instance, here I have a function higher order, and if I want to pass a function that takes another function, then I pass in the parameters of that function and the return value. So what I'm doing here is I'm saying this function takes another function which takes 2 integers and returns an integer. Okay? That is essentially how you declare a higher order function in Kotlin. So when I want to call it, I would do something like higher order, and then I can now pass in anything that matches that signature. So we had a sum function before, and I can reference it as sum, right? That's how you reference a function by name, using colon, colon. So that allows me to pass in existing functions. What if I want to pass in a lambda? So I can pass in lambdas as well by doing x, y, and then the actual implementation, x plus y. And that is the signature for lambdas in Kotlin, right? Again, type inference, you don't need to be explicit. Now, we follow some conventions similar to, for instance, Groovy, where if the last parameter of a function is another function, you can put the function outside of the brackets. If it's the only parameter, you can remove the brackets. They become redundant. And then I can take this, for instance, and create it, in fact, in multi-line, right? Which, again, you'll think, why would I do that? Because it's an awesome demo. But it also allows us to, in a way, extend the language as well, right? So, for instance, a very wonderful use case is in C#, you have using, which essentially takes something that needs to be disposed of or destroyed and destroys it after you use it, kind of like the equivalent in Java, which would be try with resources. In Kotlin, you could actually implement something like that yourself, just creating a top-level function called using, which is takes a closable and then a block of code, closable, closable, and then a block of code which takes no parameter and returns not unit. And then here I could say something like try, and then finally object close. And then in my code, essentially execute that call. So now, if I use that, if I have, for example, an object that's closable, it really does look like it was part of the language when it was created. Okay? And so this is essentially like higher order functions, and then we have anonymous functions, and you know, you can have functions or return functions, etc. And this now leads to a little bit what you can do with Kotlin, which is some of the beautiful things around DSLs. So let's go ahead and create a nice little DSL over here. Let's go to DSLs. Okay, so any of you familiar with web development apart from Russell? Right. And Sinatra, ever heard of Sinatra or, yeah, Rails, or all of these, Node.js? Now, I know that people are shy to put up their hand because it has that association with JavaScript, but So I love Node.js. Well, I love Node.js. I don't like Java. No, never mind. So there's a framework that I used to use a lot in JavaScript, which is called Express.js, right? Which is kind of like Sinatra from Rails. Well, from Ruby. And Sinatra has this, like, it's essentially like a servlet. It's like an HTTP endpoint. So I want to do something along those lines, right? So I want to create a function, for example, that says get, that you give a path to, and then you give it a request object and a response object, right? So I can say, for example, it has a request and a response, and then it returns unit, right? And now, let's create a class request, for instance, which would be, for example, it would have the accept, the HTTP accept header that's being passed in, and the length, for instance, of type int, and then we'll create a class response, which has the content, a status code, for instance, and the actual content, okay? String. So now I could do something like get, home, and then pass in my Lambda, and it kind of looks nice. It's like a DSL to write my web server. The problem is that I have to now explicitly write this request and response, and then do something like, if request accept equals application JSON, then do whatever, right? I want to get rid of this, because it's noise again, right? Now, one thing that I told you, we didn't tell you, we've got another convention in Kotlin, which is if a Lambda takes a single parameter, you can refer to it as it. So what I could do is, in fact, take these two and create a new class which is called handler that encapsulates these two, right? So something like that, request and then request and then response, okay? So now I could do something like, instead of having this explicitly indicated, I could do it, request, it. Oh, they need to be properties. And that's how you pass in parameters without them being properties. So it request accept. Now I get my nice little, get rid of that noise with the lambdas, and I've got the it. That kind of sucks, because why do I need to have this it? I'm referring to the request object. Is there a way for me to have that request object? So you notice the concept of higher order functions, which we just saw in Kotlin. And I also told you that Kotlin has this thing called extension functions. And now this is unique to Kotlin. We put those two and two together. That gives you 4. And what we do is you can have what we call lambdas with receivers, which is essentially, instead of having a function that takes another function, you can have a function that takes an extension function. So here, instead of taking a handler, what if I were to pass in an extension to handler? If I pass in an extension to handler, what will happen? That means that now my Lambda has access to the properties of that class, in this case, handler. So I can now refer to that class directly, right? To that property directly. I refer to a request directly as opposed to having to prefix it with it. So now I could do, OK, that's wonderful. And now I can say, for example, response content equals, and let's put some JSON, which we'll try and, or JSON, and now we'll do edit, and now write JSON properly. Oh, where are you, my friend? So this is why you shouldn't try and do things live. Name equals me, okay? And there you go. So this is nice again, but I don't want this. I want this. That's what I would love to have, right? Now, could I possibly do this? Well, in order to do this, let's look at what response is. Response is what? It's a property of type response. And what I'm essentially doing is I'm treating this now as a function call. Can I do that in Kotlin? Actually, we can. So if I have a class called foo, what I could do is create a val foo, create a new instance of foo, and then invoke val, invoke foo. How do I do that? By creating a member function which is designated as an operator called invoke. As soon as I do that, now I can actually invoke that instance. Okay? So if I can do that for foo, I can do that with response, right? And I don't even need to know Kotlin. I just need to know alt-enter. And I just say create member function in response. Now, however, what is the parameter that I need to pass in here? Well, given that I want to have access to what? To content. What is content? Content is a property of response. Therefore, I need to pass in an extension function to response, right? So I could do response and unit, okay? And now, voila, I have my DSL, okay? So combining higher order functions with lambdas with receivers, with some of the conventions that we have for creating passing in last parameters without omitting the parentheses, all of these things, these are what allow us to create these DSLs for Kotlin. And these DSLs are useful not for demos and not to create these full-blown HTMLs, but inside your application. Think, instead of me having to create configuration classes, I can create tiny little DSLs. If I'm doing anything around domain-driven design or specifics around a specific domain, I can create these mini little DSLs. This is where the true power of DSLs come in these mini DSLs that you're trying to do. Okay? So that's a little bit around the language. And why is that not gone full screen? Yeah, full. So as you see, we've seen a little bit around the language. And how does this now fall in with Kotlin Native? So Kotlin Native, as I showed you, it allows you to target all of these different platforms. We're using under the covers LLVM. And we have exceptions, we have memory management, we have interoperability with C, Objective-C, Swift, and all of the done via libclang. Someone famously said, I don't know who it was that says not even C++ interoperates with C++. So no, we do not have interoperability with C++. Platform libraries, we provide these. So Kotlin comes with a set of standard libraries, right? And when you're using these standard libraries, we try and provide you the same experience of the language independently of where you're using these libraries. So I have a whole bunch of functionalities dealing with collections, with lists, with strings, all of these as part of the standard library, which is independent whether I'm using JavaScript, targeting JVM, or native. However, when we enter into the realm of specific platforms, that's where we start to provide certain other libraries. So for instance, we have platform libraries that provide you with the POSIX implementations of some functions on some platforms. Win32, you can call out to all of these. These fall under the realm of the interops part of Kotlin. Under the covers, what it's doing, essentially taking Kotlin source code, the front end is a Kotlin compiler, shoving that to the LLVM, using intermediate representation, and then basically giving you the platform binary, right? So you have cross-compilation. You can use one platform to cross-compile to another one. In terms of the compiler, it shares the front end with Kotlin JVM and Kotlin JS. So essentially, that means that anything that the language has, you will be able to use across different platforms. If you get into the specifics of a one platform, obviously what that means is that if I want to target native, I cannot use something from the JVM. But in terms of the language itself, I can. The compiler is written in Java and Kotlin, and it produces the bit code. Now, what about memory management when it comes to native? So here we have automatic reference counting with cycle collectors. Right? So similar to Swift, and then you have the cycle collectors to sort out issues in terms of cyclic references. We also have, well, what this means, though, to make it very, very clear, if you are exclusively writing Kotlin code targeting native and only writing Kotlin code, you do not have to worry about memory management. I mean, within the realms of not worrying about memory management. Like, you don't have to worry about freeing things or things like that. If, however, you are interoperating with other platforms, such as C, then there are specific APIs to deal with that. We have weak references, which are recently been added. And in terms of sharing memory model, different threads have disjoint object graphs. So essentially, anything that is mutable, it cannot be shared across threads. Right now, this is performed at runtime. There's no compile time checks for this. Now, what about in terms of embracing ecosystems? So, as I said, it is interoperable with C, Objective-C, and Swift by association. And that means that Kotlin can call C, it can call Objective-C, and vice versa. Kotlin can extend Objective-C classes, and vice versa. And the memory manager is aware of the Objective-C runtime. And in fact, we have an application on GitHub, which is for Kotlin Conf, which we held the first edition last year. We created an iOS and an Android application. The Android was written entirely on Kotlin JVM targeting Android, and the iOS one was written entirely in Kotlin targeting iOS. Okay, and it made it through the App Store, and nobody knew. How do the mappings work? So because numbers are mapped as is, right? So an int will be essentially an int. Strings are converted. Collections of classes are wrapped. Kotlin declarations are wrapping C entities. So for example, there's ways to wrap structs, unions, etc. Type defs can be mapped to type aliases. A lot of this information in detail is available on the Kotlin/Native GitHub repository, giving you explicit tables of mapping and how things are actually mapping back and forth. I do want to get to a small demo and show you how this works. And we have the concept of a klib, or a Kotlin library, which essentially allows you to have reusable Kotlin code and then call that from your multiple Kotlin objects. And obviously, you can link in static libraries, dynamic libraries, etc. So let's see some more code quickly. We've got about 5 minutes. And this is where I launched CLion. You can tell we've just released some products. So here I have, and please do not judge my C code. Here I have the wrong project. Well, it is that project as well, but I want to show you first. So here I created my awesome little C library, right? Just to point to you, I've got a print hello world that takes void, and then I've got a print message that takes a char, and then I've got a structure and all of that. And this is essentially compiled down into a libc utils.a. And then what I'm going to do is I'll open up the actual project that uses this, right? So in this case, what I've got is we have this file called a definition file, which essentially tells us the headers that we want to, the libraries that we want to interop with. This definition file then is used by this tool which we have, which is called cinterop, which essentially creates the klib kind of calls for this so that you can actually write Kotlin code when you are calling out to C libraries, right? So I'm including the definition file with the header files that I want from C to be included. And then if you see in my code base here, for example, I have print hello world, and that is just essentially Kotlin code, which we can navigate to, and it is the header of what will essentially at runtime either dynamically or statically link to the actual implementation of that function. Right. This is the struct that you saw from before. So I have data from C, so that's a struct. We have the concept of arenas or regions for local memory management, etc. So you can essentially call out anything in terms of C libraries. And again, on the GitHub repository, we have tons of samples. Like, for instance, there's the libcurl, right, which is essentially a library. In this case, I'm saying that I want to get all of the headers, declarations from a curl library, filter out something that I don't want, so I don't have to bring in everything with me. And then inside the Kotlin code, you can see that I'm essentially writing Kotlin code calling out to curl. Don't ignore the red. That's just indexing. You can always blame everything on indexing in CLion, our platform. But yeah. Yeah, so that is essentially the code that it will write. So, we've not reinvented the wheel. The idea here is to actually really embrace everything that's on the existing ecosystem to be able to interoperate with it. Okay? And as I said, all of these examples are available and tons more on the GitHub repository already. In terms of tooling, where does that leave us? Right now, yesterday we just announced app code functionality for C-Line Native as well. So that means that you can target iOS, et cetera, using app code, which is our Objective-C Swift tool for mobile development. And C-Line right now, Kotlin Native supports. We're moving away from, or let's say we're moving to Gradle as the build system. The examples that I've shown you here use CMake, but we will be embracing Gradle for now. I know that it's not everyone's cup of tea. Sometimes it's not mine either, but anyway. So in summary, the idea behind it is to have a concise, clean, pragmatic syntax, embrace the existing ecosystems, not reinvent the wheels. And recently, in fact, just yesterday, someone was tweeting saying, I'd love to, I work at a company that I can't just rewrite my framework or my application in the next fad that's coming out. And they were pointing to Kotlin. And, we have always sent completely the opposite message. For us, it's not about rewriting everything in Kotlin. We wrote Kotlin from day one to interoperate with 10 years of legacy code base that we have on the JVM platform. And we will keep that promise of interoperability, because it is about gradually using Kotlin, writing new code in Kotlin, and when you want, when it makes sense, migrate code to Kotlin. But nothing is saying to you to throw everything out and re-implement the wheel. And Kotlin Native is essentially about taking Kotlin everywhere, right? It is about taking it out of the JVM, taking it to all of the different platforms, including WebAssembly, as I mentioned. When will we be shipping? I can't give any dates right now. The tooling still needs a lot of work. We are aiming to ship sometime in winter. Now, I won't go into specifically into what year. Or where winter, because depending on where you are, winter can be longer or shorter, but it will probably be winter. Okay, jokes aside, they're saying that potentially this winter, but winter can be long, especially with climate changes right now. So, yeah, thank you.